Hi there, welcome back to Severe Weather with Mr. CV. So the first thing, since this lecture is going to be on lightning, you can see a video of lightning that I took on August 14th, 2020. So see what happened. Okay, well, that wasn't the best quality, unfortunately, because that's all I could record with at that time. But that was cool to me to catch that. And this was taken when I lived in South Carolina. And there are in that part of South Carolina, Somerville, you can see what this channel is called. Um, there are thunderstorms almost on a daily basis in those months, those late summer months. Um, that leads us to this lightning climatology. You can see where the most lightning strikes happen. Um, Central Africa is the most of all, but we also have northern South America. We have Florida and some of the southeast. Um, just mostly in the tropics to mid-latitude areas is where we have lightning strikes the most. Um, this channel is called Somerville Weather by ICB because originally that's what I was based out of, but I no longer live there. That's not relevant, but I'm just saying. Um, so there's three types of lightning that we're going to talk about. We have cloud to ground lightning, cloud to cloud, and intra-cloud. The video that I showed you was cloud to cloud. You could see that that lightning kind of looked sideways. It didn't go all the way to the ground. Um, and since you could see the bolt, it's not intra-cloud. But cloud to ground is 20% of all lightning strikes. It typically occurs from negative charges in the mid levels to positive charges near the ground. So we're going from negative charges to positive charges. That's the most common, 90% of the time. The other 10% of the time, we have a positive discharge, which is where we're going from positive to negative charge. And we're going to talk more about that later. Cloud to, sorry, cloud to cloud ground or lightning spreads between two or more clouds and can travel hundreds of miles, typically in the anvil of the storm. Then we have intracloud lightning, which occurs within the same thunderstorm, and it's hard to see during the day, but in the night, you'll see it as the cloud being illuminated. So there's two things that we want to talk about with lightning, which are voltage and current. Voltage is the difference in electric potential between 2 points. It's measured in volts. V Voltage is a power source determines how far it will potentially spark or arc, so it can help us know the distance. Lightning flash voltage is 30 million volts approximately, whereas a household usually only has 120 volts. So that shows you the difference. Current is the stream of charged particles moving through an electrical conductor or space. This is measured in amps or A, represented by the letter A. Um, and lightning flash current is 30,000 amps about, and household current is 15 amps. This is what is the killer in lightning and what's dangerous about it. So some statistics about lightning. 25 million flashes annually occur in the United States. The number of strokes per flash is 3 to 4. The duration is zero point 0.1 to zero point 0.2 seconds. This is a famous image of two brothers that were hiking and unfortunately were struck by lightning. And by their hair standing up, we're going to talk about this in a second, what that means. But you can tell from that they were probably about to be struck by lightning. Now, a story about these brothers, the picture was taken by their sister, who was also there, and they got struck by lightning, and the younger brother here got severely injured. Um, it is a common misconception, someone that people say that one or both of them died. They actually did survive, but this brother had long-lasting injuries from the event. So that shows you the danger of lightning. Um, so ions, if we're talking about ions, they're atoms or molecules that can lose or gain an electron. For it to be a negatively charged ion, it has an extra electron. We know, hopefully, that electrons have negative charge. A positively charged ion is missing an electron. And remember, typically negative discharge is more common, which when we're talking about that, we're having negative charges in the lower part of the cloud and positive charges below, and the lightning strike is discharging. Lightning is the arc between negatively and positively charged ions. So what is a stroke? A stroke is a discharge of electricity between the ground and cloud. And like I said, there's typically three to four within a lightning strike. There can be three to four strokes. And there are two main types of configurations that we can have. We can have a dipole configuration where we have positively charged ions located above negatively charged ions. And we can have what's called an inverted dipole, which is reverse of that. But the more common thunderstorm setup is the tripole configuration, which is shown in this image here, where we have negatively charged ions between two regions of positively charged ions. So we can have positive on the ground, negative in the low part of the cloud, and positive in the higher part of the cloud. If we have a lightning strike that's going from the negative to the positive, that is a negatively charged situation or the negative discharge. Where we have a positive discharge is where we have positive to negative, and that's called a bolt in the blue, or what we know as bolt out of the blue, where it's blue skies and we get a lightning bolt. Because if that angle of the cloud reaches over, lightning can strike down and we can have the positive discharge situation. Now, how does charge separation occur? These are the basic steps of how this happens. We have inflow and updraft that carries positive charges near the surface into the upper portions of the thunderstorms. Um, Positive ions in the upper portion of the thunderstorm become reinforced by ice crystal production. We have rising ice crystals that collide with falling graupel. We're going to talk in a second more about graupel, but electrons get sheared off with rising ice crystals through the collision with the graupel. So there's collision that's happening and electrons are sheared off. Um, Graupel becomes negatively charged and the ice crystals become positively charged. Negatively charged middle of the thunderstorm is -10 to -20 degrees Celsius. Oh shoot. Um, okay, I don't know I just clicked on something on accident. Sorry about that. Um, Graupel forms, remember, by convective processes where supercooled water accretes onto a snowflake. Lightning begins when the electric field overcomes the atmosphere's ability to inhibit the flow of electricity. As the electrical potential increases, a stepped leader forms, and we're going to talk more about this in the next video, so stay tuned. Streams of electrons surge the cloud base and they search for a positive charge. And so, as you could see in that image where the guy's hair was standing up, that is the electrons searching the surge from the cloud base. It's searching for the positive charge, and they were the positive charge in the stepped leader that it found, and it will decide to connect to that and go down and strike. So more later on that, and that will be it for this video. Thanks for watching.